All right. Well, good morning, everybody, and welcome to everybody that's joining us today to follow the journey of certified compostable food service packaging as we move backwards on its life cycle. This is our second webinar of this very special 7-part webinar series. And this morning, we're going to learn from three amazing and very experienced presenters on how compost is made using food scraps and certified compostable food service packaging. On behalf of BPI and myself, we're extremely excited to be here with you all and are very grateful to our presenters as we continue this series highlighting successful programs throughout the country. My name is Jorge Montezuma, and I'm the principal consultant of One Organics, a consulting firm working with public and private partners to develop and improve composting operations. I've been working with BPI on this series since last year, and I'll be serving as the moderator. On deck for today, we'll start off with a brief background on BPI, then describe the 7-part webinar series, then hear from our presenters, and we'll wrap up with some Q&A, and we'll be wrapping up at the hour. You're welcome to ask any questions on the Q&A chat throughout the webinar, and they may get answered in the chat itself. If not, we'll get to them at the end. We'll have a formal Q&A session after the presentations where you can ask questions for one, two, or all the panelists. Please note that this webinar will be recorded and published online. And again, the Q&A portion will be recorded, but not posted directly online. It may be used for marketing by BPI at a later date. So definitely stick around through the end to hear the Q&A session. So we'll, 58 minutes. So let's get started. I'm going to hand it off to my good friend, former coworker, and now new BPI Director of Marketing and Communications, Leslie Rogers, to tell us a little bit more about BPI.
Thank you, Jorge. Welcome, everyone. We're so happy to have you here. So BPI was founded in 1999, and we are the leading authority on compostable products and packaging. We have a vision. Our vision is a world without organic waste. And to achieve this vision, we really support and focus on the circular bioeconomy by advancing policy, standards, research, science-based verification of compostability and biodegradation. Our core objectives are claims, adoption, and policy. We see these as our key pillars as we try to achieve our goal and support the full value chain of certified compostable products. I'm going to hand it back to Jorge and our amazing presenters. Thank you all. They are definitely our composter champions. Thanks.
Thanks so much, Leslie. I mentioned that we're continuing today on the second webinar of this 7-part webinar series. And this is what our journey looks like. We're going to devote single webinars to various portions of the life cycle, working our way backwards. We launched last month with using compost made with certified compostable products, where we heard from Spurt Industries in Michigan, AgriCycle in Pennsylvania, and Nature Cycle, with projects in the Northeast on how compost made with food scraps and certified compostable food service packaging is made and used. This compost is used in farms and all the way up to rooftops, meeting various different types of quality standards applicable for a variety of uses. These companies manufacture and or use high quality compost in different applications with great success and demand. Now, today we're going to dive into making compost. Then we'll continue to learn about municipal and private collection programs in the summer. As we move into the fall, we'll learn the details of the BPI certification process. You can find that online, but we're going to have a webinar to explain that as well. And lastly, we'll wrap up the year and welcome the next one with learning about how certified compostable bioplastics are made, as well as fiber products. Throughout this webinar, we seek to highlight successful programs and best management practices that could be used to improve programs throughout the country. First, we're going to hear from Andrew Brousseau from Black Earth Compost, then from Jake Duame from SET, and then from Dustin Montey from SMSC. So now I'm going to pass it off to Andrew to launch us into the first part. So I'm going to stop sharing my screen. And I'll introduce Andrew. So since 2011, he has been the head composter at Black Earth Compost in Massachusetts. In the last 4 years, he has developed and managed 4 composting operations in the state, composting about 10,000 tons of food waste per year. He's trained as an earth scientist and was previously an oceanographer, drawn back to land to work on society's nutrient recycling problem. And we're super happy that you're here with us today on the webinar and in the industry. So thank you, Andrew, for sharing about your operations today.
Cool. Thank you. Yeah, I will dive right in, but also caution you, we're like right in the middle of our spring, and so I might be a little tired. But let me talk about what we do here. I think compostable packaging, food waste, and yard waste are, I call them municipal best friends, because they all exist in municipalities. They're all waste, and they can all go together to make compost. And so I think they go together, and municipalities, it's a best friend to them to have a composter, because we think we can provide these collection services for the lowest cost possible. And that's what municipalities are looking for. Cool. So a little background, Black Earth Compost, we both collect and produce the compost. These are our trucks. You can see our municipal bins are these small ones on the right, and we also collect from commercial also. And we produce a high quality compost for people to grow food with, right? Whether you're a gardener or a farmer. This is what our food scraps look like. We are heavy in compostable packaging. We take a lot of it, and that's because our customers want it. We have 40,000 residential customers in Massachusetts, and you know what? The liners really help them out, keeping their bins clean. And that's part of the reason we are successful, is we're able to keep the bins clean for customers. Now, you know, there's like the bin swap programs also, but we find that those are higher cost. So we're able to provide our lower cost service to customers because of liners, because they help keep these bins clean. So that's the direction we've gone, and I think it's been successful, as shown by, you know, 40,000 residential customers. We're in 133 towns. Just keep an eye on time. So we have 4 compost facilities with 4 different processes. We collect about 300 tons of food waste each week, and that goes through these facilities. You know, if you want to talk total tonnage, it's probably then, you know, 600 or 500 tons total product each week going through, you know, green waste and food waste and green yard waste. So each site is about 2.5 to 4 acres. I know we'll be hearing from the other presenters who are at larger scales. So we're at this scale, and I'm going to talk about strategies of how we work with compostables and get trash out based on this scale. So these strategies might not work at other scales, or they might, but this is what I've found works. And the reason we're at this scale is because we're in Massachusetts and there's no land. So we have to be on small footprints, and we have to push a lot of food waste through small footprints. And that kind of leads to our decentralized model, which is, you know, puts the compost sites right where the resources are, right? Food waste, yard waste, and compostable packaging. You know, homeowners handle a lot of compostable packaging, and, you know, that ends up being a large percent of the waste. And if you're not capturing that, then municipalities aren't able to divert as much. So they'll end up, yes, then you can't recycle as much with your organics program compared to if you do accept compostable packaging. So the decentralized model also lowers the cost for trucking distance, right? Because our trucks just come out, they collect the food waste, then they go right back. And then the finished product is right where people need it. Or we can get it out to farms, which are usually outside, you know, the metro areas. And then our growing food for the metro areas, which is the big picture, right? How are we going to get this food waste back to grow food for us. So this is just an example of what, homeowners deal with all this stuff. It's all food contact packaging, and a lot of it, like, recyclers don't want, or they can't handle it. And maybe they're trying to figure out how to handle it, but maybe they shouldn't, right? Like, some of these things, I know we're trying to figure out how to, like, line paper, or we are line paper with plastic, coffee cups, ice cream containers, whatever. So they're trying to figure out how to recycle that to remove the plastic. Well, I'll tell you, they're not going to get all the plastic off, and you're going to end up with microplastics in the recycled paper stream, even more. So let's just make those liners out of something that can degrade and go away. It's a great end-of-life solution to turn all this crud compostable. So we like compostable packaging. So I'm flying through, but I got 10 minutes. What are the practical reasons we like it, not the big picture stuff? So it provides bulkiness, so it gives us airflow in our pile. It's a source of carbon, it's pre-mixed, and so it's already like absorbing liquids, in the truck and in the bin. So that's nice. Helps make the food waste a little nicer. And trash is going to come in either way, so it might as well be compostable. And from the hauling perspective, like I said before, liners, they increase food waste collection because, we're able to keep our costs down using liners as opposed to bucket swap. So that means we can actually be a solution for municipalities who are extremely cost sensitive. Not to mention, liners help people in their kitchens who have the gross factor, or in their bins outside. And compostables can bring more volume and thus revenue to the composter, right? It's kind of like shifting revenue from the recycling collection over to us. So great. And it separates our service from what anaerobic digesters offer, right? Because we can actually be part of a future where food contact packaging can be recycled locally rather than being kind of, depackaged, shredded, microplastics into the trash. So yeah, that doesn't sound great. So that's something composters you can use to, like, separate yourself from digesters. Right. So, why do we like third-party certification? So first of all, it protects compost quality. Second, it makes customer service easy, right? Because people come to us all the time. Can I put this in my bin? And, the customer service person can't pass the question up to me every time and say, hey, Andrew, do we take this? And, like, I don't know. So it's easy for the customer service to just say, yeah, make sure it's certified. And finally, clear labeling, right? That's important for the customer, the person at home trying to figure out which bin to put it in. All right, so strategies that make compostable successful here. It's a tricky balance because we want to break down the compostables. We need to get trash out, but we don't want to sort out the compostables. And we want to sort out trash later, but we don't want to lose the sticks because sticks give us bulking and we want to recirculate those. So the first thing is driver audits. I don't have a photo of that, but our drivers, because we're a collection and compost company, the drivers are out looking inside the bins before they pick them up. Second is load audits when it lands on the ground. You don't have to do this every time. In fact, I think you can do it twice a year on every route that comes in. And I think you'll get a lot. Because we find that a lot of the trash is coming actually from a very few number of locations, right? Like, most locations are good, but then some are bad. And so if you can get those bad ones, you can get probably 50% of your trash out just from the start. So this is the big one that we're working on now, and it's kind of where we've ended up. Sorry, is early trash removal. So in our facility in Manchester, we break down the food waste in an ASP system. indoors for 4.5 weeks. So you can see the picture on the left. This is what it looks like initially. And you can see this is what on the conveyor belt, what it looks like after 4.5 weeks. So what basically we're breaking down the compostables and the yard debris and turn it into a black homogeneous substance that then it's easy to pick out the trash. So that's a good strategy that we're working on. And you don't have to have an ASP system or indoor system to do that. You just need a conveyor and a pick station. And the key here is that we're getting out the trash early enough that it's not going to fragment later, either fragment in a screener or fragment through continued turning or exposure to heat, etc. So I also think it's cost effective because another scenario is picking windrows. I don't have a photo here, but it's like sending someone out with a tote to pick off a pile. So picking off a conveyor is a concentrated time, and I think it's efficient, whereas having someone wander around the site, which we still do. Screening, don't have to say much here. There's different types of screeners. I'm not sure which is best at this point, but I know that getting the trash out early really helps. And finally, cleaning your tailings. We have a EcoSift machine it's a density separator that separates out rocks and sticks, and it has air classification to get trash out. So that's kind of like the last step, because it's really important not to recirculate trash. Like, you cannot do that. Otherwise, you're going to have small bits of trash. And so just want to remind you of the big picture. We want to make compost using the resources, in the metro areas, and then export that to farms to nourish their soils, grow food, and then get that food back to the metro areas. Thank you.
Thanks so much, Andrew. That was awesome. I really liked, it's not verbatim, but you said essentially like know your waste streams. A lot of trash is coming in from a few locations. So understanding the sources is really key. I'm actually, in the middle of doing a waste sort right now. I'm in a conference room. So it's been really interesting to just see what's in the trash. So next we have Jake Duame. So Jake, if you could pull up your screen. He's the environmental protection specialist for the WM owned composting operation known as SET, which stands for Specialized Environmental Technologies. Jake oversees quality control and environmental compliance at the Empire Processing Facility, which manages approximately 25,000 tons of organics and other compostable products generated in Twin Cities area of Minnesota. Jake also manages the compost sampling program, provides regular outreach and education to the public, and serves as a board member on the Minnesota Composting Council. So thanks, Jake, for presenting today, and looking forward to hearing what you have to share.
Thank you, Jorge, and greetings and good morning to everyone else. Jake Duame with Specialized Environmental Technologies. I'm going to talk to you about operations located in the Twin Cities of Minnesota. So SET is privately owned and operated since 1997, or the mid to late 90s, and then recently purchased by Waste Management in March of 2023. We operate 4 local composting facilities to the Twin Cities metro area. 3 of those 4 are yard waste only facilities, so green waste and brush. Then our large scale source separator organics facility down the southeast corner of that map processes all of the food scraps that get sent our way. As Jorge mentioned, we process about 25 to 30,000 tons of organics. It shakes out to be about 500 tons per week of food scraps and compostables. About 250,000 cubic yards of brush and yard waste materials between our 4 sites. and sell around 100,000 to 150,000 total cubic yards of finished compost and soil blends per year. So this Empire processing facility, where the food scraps are sent to, opened in '97, are permitted to accept SSOM, which basically means food scraps, compostable products, and non-recyclable uncoated paper products. In order to do that, we're required to process on an impervious surface. We use a clay pad with a gravel working surface on top of that. Contact water management, so all of the water that comes in contact with that material needs to be retained in a retention pond and sent off to a wastewater treatment facility. And then managing contamination and residuals, making sure they're not building up on site, shipping them off as need be. We accept material from residential, commercial, and industrial sources. Farthest away is probably the city of Mankato. It's about an hour, 15 minutes or so drive from the Twin Cities area. And then most of the other, pretty much all of the organics are collected and consolidated and sent to our facility within 20 to 30 miles. Acceptable materials, pretty much just what meets that definition of SSOM. So any and all food scraps, paper products, and certified compostable products. We process our organics using the aerated static pile method with forced aeration. So this is a cross-section of an ASP system, kind of a general idea of what we're looking at. But we have our a blower fan attached to a thick-walled cardboard tube that runs the entire length, usually about 200 feet long piles. Surrounding that tube, we layer about 3 feet of wood chips that acts as a air diffusal system, kind of evenly distributes that airflow. Also, it'll insulate that cardboard tube so it doesn't collapse. And then we'll pile our mixture of organics and yard waste, usually about a 50-50, maybe 60% yard waste to 40% food waste on top of that. And then a cover material, usually that's our castings from our finished compost, finished yard waste compost, a lot of small sticks, high carbon material. It'll act as a biofilter to prevent some of those odors from escaping, as well as insulate those piles in the winter when things are getting pretty cold. Our composting process, pretty simple. We mix our feedstocks, our yard waste and food waste get mixed up in this industrial egg mixer. So we're not grinding up anything. There's a couple of upright augers that will slowly turn and rip open compostable bags, get a relatively homogeneous mixture of material. Those doors will open on that egg mixer, and all of that material will get pushed out by those augers. From there, we'll utilize front end loaders to pile the material onto our aeration system. And then pretty much leave them untouched for about 45 days. So that's where the static word in that aerated static pile means that we're not touching them. It has its drawbacks, and there's pluses and negatives to windrow turning, to ASP, to in-vessel systems. It's great that we don't have to tear these down. It saves on labor and fuel costs, but at the same time, that physical agitation does help break up some of those more durable materials and allow it to decompose a little easier. But we're willing to trade that off for the less labor and fuel costs, as well as releasing that heat buildup and potential nuisance odors that could escape from those piles. From there, our active piles will reach the PFRP temperatures to kill off pathogens. We'll leave them untouched for about 45 to 60 days. Then we do our first screening. So we use a 2-inch diameter trommel screen that will sort out some of those overs. The bulk of the overs are non-compostable plastics, metal, occasionally glass that gets into the organic stream. Things that we don't want to see, mostly contamination. We will lose some paper during this process. Paper just is more durable. The fibers, the lignin in that tissue just doesn't break down nearly as fast as the cellulose and the bioplastics do. So we will lose some paper, not just compostable, certified compostable stuff, but pizza boxes and paper towels if they get wadded together too tightly. We will get some of that material screened out. But our residual rate is usually between 5 and 8%, well below the 15% requirement set by the state here. So operating within our parameters in that sense. After we screen, we move the material into a curing pile, turning it with front end loaders for another, we'll turn it usually 4 or 5 more times over the course of 3 to 6 months. And then screen one last time down to a 1/2 inch. If you're familiar with the Comtex star screener, that's what we use in our process, down to a 1/2 inch in diameter. We can go smaller for a premium blend of compost, but generally a 1/2 inch in diameter is what we're selling in bulk. And then that star screener, it spits out 3 different size materials. So the fine material is our finished compost. And then there's a mid-size material. We refer to it as our 1.5 inch. That's what we use to cover up our aerated static piles to act as that biofilter. And then everything above 1.5 inches in diameter, depending on what we're screening, if it's food scrap compost, there's inherently going to be more contamination in that. Will likely get landfilled. If it's yard waste compost, pretty much it's just unfinished compost or non-degraded sticks and chunks of wood that haven't fully degraded. That'll get either recirculated back into the start of the system, sometimes reground and applied as a biofilter as well. So in order to minimize contamination, both on the front end and then throughout the process, we've adapted our process through physical equipment, as well as education and inspections. So we will inspect every incoming load of material, making sure that it's suitable for composting. If it's greater than 5% contamination by volume, that load will get rejected, in which case there's much more higher costs associated with trash loads versus clean, acceptable organics. That's what this slide highlights. A typical load of organics, if it's a 20-ton load consolidated from a transfer station, it'll cost the hauler about $1,600. That load getting rejected nearly triples that amount. So you're saving about $2,500 to make sure you are tons of benefits and successes associated with them, apart from just securing additional food scraps, which is of course the main goal. They also act as a viable bulking agent, provide carbon. It reduces our reliance on single-use plastic items, which it's fantastic that it does that. It's not the silver bullet that's going to solve all of our waste problems, but until we can get to a zero waste society, utilizing these compostables and renewable sources of plastic and paper beats the hell out of digging out oil and coal. So the opportunities are there. There are some challenges, mainly in how the compostables and traditional plastics, whether that be trash or recyclable, look. I pulled all of these cups out of the same load from the Xcel Energy Center. And if I'm expected to do an inspection on a load of organics and I see 20 different cups, it's going to be very difficult to determine what's compostable. So that's why we really rely on BPI and their labeling program, making sure that compostables are labeled and even colored and striped to be able to quickly identify something that's compostable versus a trash alternative. This is an example of a load of 2 loads of clean organics. The one on the left has relatively no compostable products in it. The one on the right has compostable products in the bags, and of course the bags themselves. So you can see how much more difficult it is to determine if there's any contamination in that picture on the right. And these are rare examples. This is much more representative of what a load will look like when it comes to our facility. And during a quick inspection, it's nearly impossible to determine how much contamination is in there. This, by the way, is a relatively clean load. I can see a few bits of contamination in there. And when I did the inspection, I pulled out a couple small bags of trash here and there, but for the most part, it was clean, but you would never know that on a very quick glance. So that's the main challenge. Pretty much the only challenge is the masking of true contamination. The products themselves break down just fine. We've been composting compostable products for 15 or so years now, and have very little issues other than that it can mask and bring along with it contaminants. Which is why it's so important to have that labeling, both for the consumers as well as for composters being able to identify it. And then just ensuring the public and entities that are utilizing compostables that they do in fact break down, they work well. So increasing transparency with different studies and outreach to the public is vital for composters to continue accepting compostable packaging. So we'll thank all the partners that contribute to those. And with that, I will pass it back to Jorge.
Great. Thank you so much, Jake. Really like, one key thing that you mentioned here that I've heard before and seen data for it is that, fibers take longer than bioplastics. So it's nice to, well, it's not nice, but it's good that, so you're seeing that as well. And that relates to what the data is showing as well in some of the studies that are out. So thanks, Jake. And last but not least, we have Dustin Montey. Nice last name, by the way, like the first five letters. And here's your screen. Yeah, if you want to share your screen, I'll go ahead and introduce you. Dustin has been working with SMSC since 2014. SMSC stands for Shakopee Medawakatong Zoo Community. I think I got it right. Not sure you can correct me. Great. He's currently the director of both the Organics Recycling Facility and Dakota Prairie Composting. With over 10 years at the facility, his previous roles include assistant manager, lead biomass processing technician, and biomass processing technician. He currently serves on the Minnesota Composting Council Board of Directors and holds a professional certification as a Certified Compost Operations Manager, CCOM, from the U.S. Composting Council. In his position with SMSC, he's responsible for overseeing all aspects of the facility, including compost operations, colored mulch production, off-site wood grinding, sales, and delivery of products. Dustin was instrumental in researching and planning the expansion of the new operation, which we'll hear about today. And lastly, prior to working for the SMSC, he served 5 years in the Marine Corps. So thanks, Dustin, for your service and for presenting about your 2 facilities today. Looking forward to your insights.
Yeah, appreciate it. Thanks everybody for coming in and giving us time today to kind of talk about these this topic here. So Jorge introduced perfect. My name is Dustin Montey. We'll fly through. I got quite a bit of slides here. So brief overview of our original facility. It's a large-scale composting facility owned and operated by the Shakopee Mdewakanton Sioux community. It is a turned windrow operation, and it's operating on 24 acres, as you can see here. Everything is paved, which is a huge benefit to composting facilities. We are in the middle of our relocation and hoping to, we'll actually be having our grand opening next month. We are doing a soft opening right now, so we actually are taking in some material in preparation for that. This facility will triple our food waste capacity, and we are changing over to the engineered compost systems, or ECS's CASP, reversing CASP aeration system. So some of the materials that we bring in are food waste, compostable products, yard waste, wood waste, and horse manure from a local racetrack. Talking about the capacities, we are about 70,000 tons per year at our original facility, and the new facility has the permitted capacity for 212,500 tons annually. Our food waste comes from SMSC Enterprises, or we also own a casino, and so we get all of the products from the casino. Some curbside collection routes, schools, universities, restaurants, businesses, grocery stores, food manufacturing. I mean, you name it. If we can compost it, we want to take it. When material arrives, I'm going to echo a lot of what the previous presenters did. A great job, by the way, guys. So, but we'll do a load inspection for each load that comes in. The unacceptable materials are, some of the main ones that we see are those glass, metals, and plastics. Those are kind of the worst ones there. But we'll use front end loaders and long handled hooks, like our operator Anna in the pictures is using, to kind of break open some of those bags and inspect those loads. We also have a 5% contamination threshold, which we're very fortunate that we were able to work with SCT, and because we are the two main composters in the area, so we have the same kind of threshold, so haulers can't say, oh, I'm going to haul it to somebody else because they'll take it. So we kind of hold them all accountable. Compostable products can make inspections a little more challenging. It's just kind of the reality of what we have. The compostable bags that you can see kind of on the left here, they tend to be able to hide contamination. So we'll see, certain individuals that will just kind of fill them entirely full of trash. You can't see that from just seeing that it's a approved compostable bag. So we do need to rip those open and do inspections inside. We'll find that there's kind of a lot of misleading products that I'll touch on later that we'll find commingled. And so sometimes that makes it challenging. All of those black cups that you can see on the left are compostable. There are, I couldn't even pick them out in this picture, but there are some almost identical black cups in there that are not compostable. So those are some of the challenges that you'll see. We do sometimes get loads that come in that are very contaminated. I think it just kind of happens with everybody, right? The problem is when they break open and contaminate the entire load, it becomes almost impossible to try to fix that situation. Sometimes we can, it just depends on what's in there, if we have the ability to screen that out later. So what we do here is we work with about 15 to 20 regular haulers that come in with routes. They're primarily coming from the 7 to 10 county metro area around Minneapolis, St. Paul, Twin Cities area here. But we do have several routes that come from greater Minnesota, and we have a few routes that come from out of state. So we rely on our haulers to help with the contamination. Haulers pick up from many different stops, and it's just not feasible for us to go and talk to each generator on those and each one of their routes. And so for that reason, I do try to provide some identifiers. So what you can kind of see here, the top left picture, that whole load was full of stickers from a local grocery store. So we're able to go back to the hauler and say, hey, do you pick up, will you pick up from, Cub Foods? They're having some serious issues with contamination. We need to go and re-educate that generator. Some of the other things you still see are maybe receipts, or bottom left is from a hospital. It's a food order form. And then on the bottom right is the generator's address. So we will go through and figure out, if we can, where is it coming from? And then we try to go right back to those people and educate them. There has been times where they just can't figure it out, and they end up getting their routes cut because they're contaminating the entire load. Conversely, there's been, we had a McDonald's that was consistently having just a very high level of contamination. They were adamant that they were doing everything the correct way. When it came down to it, and they reviewed cameras, they had an unlocked dumpster, and people were filling it with trash. So they put a lock on it. It's been an incredibly clean route ever since. So just kind of an example of how to kind of work back and try to figure out, from, if you can identify a generator, that if you can work with them, that might fix your issue. We also had a hauler. This is a great success story. They pick up from a wealthier city where I would say kind of appearances mean a lot to the individuals that live there. And they instituted a 3-strike policy on their curbside cart. And so if the hauler opened up the cart and saw contamination, they put a big red X on top of their lid. And before that hauler could even get finished with their route, 9 times out of 10, those residents were calling and begging to get that X off of their cart because they were embarrassed. They did not want their neighbors to see that they had a red X on their lid. And in that program, if you had 3 X's, you're out of the program. You're no longer allowed to participate. So great success story there. We've had it kind of roll out in several other neighborhoods, and we've had some success. We've had some that just don't care, but it is something to kind of think about, because I was actually kind of amazed at how well that worked. While working with all of our haulers, we have shared box account. So each hauler has a folder that they can access. If we have a load that does have enough contamination, or even just contamination worth noting for them, we will take pictures. We kind of document everything that we can. We'll upload it into their shared folder and then send them an email to notify them, hey, truck 56 had significant level of contamination. They're able to go in, see the pictures, and then if we can provide those identifiers, we'll do that as well. The reducing contamination, it's definitely a challenge. There are a lot of strategies that we can do, and these are kind of some of our largest success stories that we found. Once we kind of work with the haulers, at least, they want it to be successful as well, because that's how they're making their revenue. 1 second. Then there's a lot of misleading products. I think these are probably our largest challenge. You might run into a lot of these where you're doing load inspections. Some of the items are meant to look compostable, or they're purposely misleading is the best way I would put it. Some are making just flat out false claims. A lot of the terms out there can confuse customers and consumers. When they are trying to do the right thing, they just don't know, and that's probably one of the most frustrating things. But this is why that we push in all of our messaging. I want to see a BPI logo. That's a logo and a name that I can trust. It's easily identifiable for our operators. Like when you see in those pictures, this is large loads being dropped. It makes it very challenging to try to identify with all of these kind of, I guess I'd say, marketing misleading logos and statements. So I have a few other kind of some pictures or some that we see kind of regularly. Sustainably managed forests, recyclable if recyclers accept food soil papers, which I don't, there's none around here that do. Renewable resources, made from renewable resources, bio-based. These are all wonderful things. They don't mean anything for us. We can't compost it. So once we do get those loads in, and we start to process those cleaner organics, there's still going to be some contamination in them. The composting begins. All materials run through a shredder, and that helps to open up those bags, produce a consistent particle size, which we need for our composting recipes. The rows are around 500 feet long, 10 feet tall, but the rows are only about 20 to 30% food waste, and that's to get that good carbon to nitrogen blend. So the rest of that row is a mix of yard waste or wood waste. The materials are actively managed in those windrows for 80 to 90 days before they're moved to either screening or curing. And I wanted to kind of show, we screen all of our food drives compost through that star screener that Jake showed in his slide. We also have 2 Comtech L3 and an XL3. The materials, those screeners have 2 wind sifters on them, and they act kind of like a vacuum, which help pull that light film plastic. And you can see on the left, that's a walking floor trailer. That's about 2 to 3 windrows of material that pulled that amount of plastic and contamination through. As well as we also operate with magnetic head pulleys, so you can remove some ferrous metals. The other kind of picture that you'll see here that we did try, I just wanted to show that the middle is kind of a before picture of what a turner looked like. On the right is what it looked like after we tried to go through a row to see if we could kind of break up some of those products, and you couldn't get through an entire row. So something that we tried and it didn't work as well. But about 80% of what you're seeing here is non-compostable plastics or other type of contamination. And then I'll try to quickly go through. Another myth that I wanted to quickly address was that compostable products don't break down, and they do in an ideal situation. Some of the things that we'll see where we run into challenges is that you'll see haulers or generators stacking cups or molded fiber trays to try to save space in their dumpsters, and then you can kind of see what happens is they bind together, and that's a challenge to break down. But if you have the ability to kind of break those up, we don't see those issues. Compostable products, they don't always arrive the way that we would like them to arrive. And so you can see on the left, that was stacked and went through a shredder, and that's still kind of what we found in a windrow. And then really quick, same thing with schools that use molded fiber trays. They'll stack lunch trays and it turns into this kind of big pulpy mass. But if you can continue to break it up, it will break down. A couple other challenges that we see are rolls. Everything here is compostable. I couldn't find one of bags, but when they expire, we'll get entire rolls like that. Those are also a challenge. But again, it's just because they're not arriving the intended way to break down. So, but they will break down. It's a challenge that you kind of have to work through. 5 to 6 months later, this is some of our finished products, and you can kind of see, you know, that we had a before picture on the left, and then we kind of hammered down on contamination on the right. And we're producing, you know, 1/2 inch minus compost. Not all compostable products are going to break down initially when they're stacked like that. Those screeners have the ability, which we kind of set them so that you'll get the kind of pulpy mass molded fibers to come off in a seconds or an overs size, and then we're able to reintroduce that back in the process, and eventually you'll see that material break down. And then just quickly wanted to touch that, you know, it's very important for us to have high quality finished products. We serve a lot of bagging companies, and then a lot of homeowners and gardens and kind of just areas where any composter here knows you have to have a very fine or a good quality product, or you're going to hear about it and you're not going to get a repeat customer. So I just wanted to touch on that and say it is very important. And so we are finding success. It just kind of have to fine tune that operation slightly. The last thing I kind of wanted to say was, have a good outreach and education plan. If you bring everybody along as a team, from the food and the products manufacturer to the waste generator, the hauler, the composter, and the compost user, every single person in that chain wants it to be successful for one reason or another. And so if we can just work together with them, you know, you start on the hauler side, they want the money, they want the tip fee. But if we kind of start sticking them with reloading fees or rejected loads, they're having issues with compliance. So they want it to be successful for a different reason, but they still want it to be successful. So it's just kind of working as a team with everybody and carrying them along, and kind of making sure everybody has a voice. And oftentimes we just find that we have success that way. Thank you.
Thanks so much, Dustin. That was great. Let me now share my screen. Yeah, I really like the X, tapping into social dynamics to help with contamination. That was, I haven't heard of that one. So I'm gonna wrap up now to close out the recording before we move into the Q&A. So thank you all three for sharing so many details, insights, and lessons learned about how you successfully compost food scraps and certify compostable food service products. And people can they can probably easily find you on LinkedIn or through, you know, looking at your websites as well. We talked about this offline in the past few weeks, but if people have any questions, they're able to reach out to you, correct? Awesome.
Absolutely.
Thank you. And we invite everybody to join us on webinar number 3 in early July as we explore municipal strategies for collecting food scraps and compostable packaging. We've got 2 speakers, and hopefully we're going to have a 3rd one soon, but we got a few months, so definitely you know, be on the lookout for that information. And let me share another screen here, and don't forget to log into bpiworld.org/webinars to find out more information about all the webinars. So thank you so much.